which has been nicknamed the Sea of Stars, which has been nicknamed the Sea of Stars, which has been nicknamed the Sea of Stars. As night falls on certain beaches around the world, the waves glow with an eerie blue light, tiny neon dots that make it look as though stars are washing up on the shore. The phosphorescence only occurs when the microorganisms are agitated, such as when the water crashes onto the shore, or someone steps on the wet sand, or a paddle hits the waves. The surreal scene arises not from magic, but from plankton that have evolved to glow in order to startle or distract fish and other potential predators. Some of the most spectacular photographs have been captured from one location, Vadu Island, Maldives, which has been nicknamed the Sea of Stars. The Maldives is a tropical nation in the Indian Ocean, composed of 26 ring-shaped atolls, which are made up of more than 1,000 coral islands. The spotting of the Sea of Stars is dependent on climate and the plankton growth throughout the year. Visitors to the island have stated they have the most luck seeing the blue glow from about July to February, especially during a new moon, since the darkness of the sky helps intensify the light. The glowing blue waters are caused by a natural chemical reaction known as bioluminescence, where microorganisms in the water are disturbed by oxygen. The result is a glittering and sparkling seawater. As the waves crash on the beach, the water glows in the dark and gives the impression it is acting like a mirror that reflects the sparkling stars above. The phytoplankton's blue glow is like a defense mechanism, which wards off other marine organisms from eating them. Although this phenomenon of bioluminescence blue glowing water occurs on many islands and locations,
far below the ocean's surface, life has adapted to a world of darkness. Strange creatures haunt the crushing depths, some of them completely blind, others with eyes that point upwards to help them avoid predators attacking from higher levels. Others still have eyes so enormous, you begin to wonder, if it's so dark at these depths, what are these eyes designed to see? No sunlight penetrates the deep water of the ocean. But this ecosystem is by no means devoid of light. It instead shines with one of the most widespread adaptations in the ocean: bioluminescence. Many creatures have evolved the ability to glow in the dark, either by harnessing bioluminescent bacteria or initiating a chemical reaction within their own bodies. These unique adaptations have intrigued scientists for decades. But more recently, researchers have realized bioluminescence isn't limited to the darkest parts of the ocean. In fact, the proportion of animals that glow is similar at all levels of the ocean, from the surface down to the sea floor. Bioluminescence is less a special ability than a widespread adaptation in the sea. More than 75% of organisms in the ocean can produce their own light, from the smallest bacteria all the way up to large sharks. The terrestrial organisms with the ability to produce their own light are a few species of fungi, arthropods like fireflies, and a handful of larvae like glowworms. And while the ocean is certainly a dark place, our terrestrial world is bathed in darkness half the time too. If bioluminescence isn't in fact limited to the pitch-black depths of the ocean, why does it seem to be constrained to barely exist on land? What is it about the world of water that makes it so much more suited to bioluminescence? They can use intrinsic bioluminescence, in which they mix chemicals in their own bodies to produce photons of various colors and intensities. Or they can use symbiotic bioluminescence, which requires cultivating colonies of glowing bacteria in specialized organs. The chemical process involves a molecule called luciferin that generates light when mixed with oxygen and a luciferase enzyme. Luciferin and luciferase are generic catch-all terms in reality. There are many different molecules that can be combined to catalyze this light-emitting reaction. This process likely originated with bacteria, and some researchers hypothesize it's incredibly ancient. The first bioluminescence may have appeared between 2 billion and 500 million years ago, and the trait seems to have taken longer to appear. A fossilized ancestor of fireflies from 100 million years ago was discovered to have a light-producing organ, suggesting that this has long been an adaptation among that group, and it probably originated as a form of defense to war. Jellyfish and siphonophores are some of the best examples of creatures that use light to evade capture. Nearly all of them have some form of bioluminescence. Comb jellies flash brightly to startle predators, while siphonophores can produce a constellation of small lights, mimicking plankton to confuse predators. Some jellies even release a glowing slime that sticks to their predator, a strategy also employed by tiny crustaceans called ostracods, or sea fireflies. When fish try to swallow them, they release one of the brightest lights in the ocean, momentarily blinding the fish and smearing it with light. By illuminating themselves or their predator, these organisms might also be calling over an even larger predator, the ones who might eat the smaller organism's would-be predator. Consider dinoflagellates, those single-celled plankton that can produce such wonderfully glowing waves. There are many species of dinoflagellates, and those that are capable of bioluminescence are less likely to be eaten. This could be because their bright flashes act like a burglar alarm, essentially announcing to the nearby ocean dwellers, "Hey, this crustacean is trying to eat me. You want to come eat him?" The last way swimmers use light as a source of defense sounds the most counterintuitive: light as camouflage. The deeper you go in the ocean, the less light filters down through all that water. Between 200 meters and 1,000 meters lies the mesopelagic, also known as the twilight zone. Because a certain amount of light does come from above, a fish swimming above a predator would have its dark silhouette outlined against the light. To keep this from happening, they use counter-illumination. Little spots of light on their underside break up their silhouette, confusing potential predators. It's such a well-honed trick that creatures like the Hawaiian bobtail squid can change the amount of light it emits depending on the time of day, like its own glowing circadian rhythm. The story on land is a little more complicated, since lighting up in the darkness is more likely to draw attention to you than to obscure your outline. But this glow can still be a defensive strategy for some organisms, by advertising that they are poisonous. It's like a nighttime version of the poison dart frog's vibrant skin color. This strategy is used by some worms as well as millipedes. But of course, it's not only prey who are using light to keep themselves alive. Predators have many of their own tricks to lure in their meals. Members of the anglerfish family might be the best-known deep-sea dwellers to entrance their prey with glowing lures.